A data repository requires mechanisms to notify the administrator when a problem is detected. Events that take place within a digital library may require notification of administrative staff. Examples include changes to a permanent collection, or changes to access permissions, or unauthorized accesses, or rule execution failures. There are multiple ways for an administrator to become aware of situations that may require intervention. If email is enabled, a message can be sent to specified persons for each event. Events can be logged into an external event index. Triggers in the external database can be used to send notification events. Messages can be written into the system log. Rules can process the system log to extract messages that require attention. Typically, all three mechanisms are used to monitor a data repository. An example rule sends email to the system administrator if a collection is deleted. The rule uses the policy enforcement point AC preproc for RM call, which is called before a collection is removed. The AC preproc for RM call policy calls MSI send mail with the arguments admin@unc.edu, the title of the message, collection deletion, and the text of the message, collection star call name is deleted. The rule can be modified to add a status flag to the collection about the intended deletion and then only permit the deletion if it is approved. The rule is loaded into the rule base by modifying the file etc/irod/core.re. Note that updates to the rule base can be done at any time by the DataGrid administrator without taking the DataGrid down. The rule base contains 14 default policies that are executed at policy enforcement points. These policy enforcement points include setting strict access controls, defining how bulk file processing will be done, managing user creation, including home directories and trash directory, managing user deletion and what to do with the home directory and trash directory, defining session variable checks, defining how data grids are renamed, imposing storage quotas, defining how files may be registered from a remote site, defining the number of I/O streams to use for parallel I/O transfers, defining what access public users can have to publicly open accounts, defining how a storage resource will be selected, defining how a replication resource is selected, defining the number of parallel threads that can be used simultaneously in the rule engine, and defining how the physical path name is set. Additional policy enforcement points exist, but impose no additional policies in the default data grid installation. The notification example takes advantage of the additional policy enforcement points to trap a specific action. The original data grid had about 35 policy enforcement points. The number was doubled to trap a much wider variety of actions. Additional policy enforcement points continue to be added to the middleware software to enable a wider variety of policies to be enforced. Take 7 minutes to complete exercise 104. Decide which events require a notification email. Note that state information can be added to a file. A periodic rule can then check the state information and generate a report. Please load a paragraph describing your result into the lifetime library in the subcollection class INLS 624 by the end of today's class. New Zealand has established a national grid that links the academic institution within New Zealand. The original data grid provided a collaboration environment for researchers. This was augmented with a grid that links computational resources. The Broadband-Enabled Science and Technology Grid, or BeSTGRID, links computing resources across academic institutions in New Zealand. The Compute Grid is linked to a data fabric that manages data for research collaborations. The data fabric uses the iRODS data grid to provide both data sharing and data staging. BeSTGRID is used to stage data to high-performance computers. For long-term data storage, separate repositories are used. Each researcher in New Zealand is given 20 gigabytes of storage. This is sufficient space to manage and build applications. The BeSTGRID data fabric was originally established in 2009 to support geo and biosciences. An example is the sharing of seismic data from an earthquake in New Zealand. The data fabric is now part of the New Zealand eScience infrastructure, NESI. The institutions that are linked by the data fabric include universities in Auckland, Canterbury, Massey, and Christchurch. Specific data management services include replication of data sets between Auckland and Christchurch and management of data privacy. The new services that were added include data transport to HPC facilities. An example is the NIWA supercomputer, which was established in 2013. A lesson from this is that large-scale computational resources need to be integrated with similar large-scale management for data collections. The interfaces that have been used to interact with the data fabric are very similar to those used in other national data grids. They include iCommands, which are used to manage high-performance data transfers, Fuse, a user-level file system that enables the mounting of a data grid as a local directory on the researcher's laptop. Applications that run on the laptop can directly manipulate data stored at other sites through the data grid middleware. Globus Online File Transfer Service. The Globus service is used to manage data transfers to supercomputers. WebDAV. This provides a drag and drop interface for laptops. Files can be dragged from the data grid onto a local directory and vice versa. Client interfaces that link workflow management with data management are now emerging. An effort at RINCE and the DICE Center is the packaging of the discovery environment from the iPlant Collaborative to improve the ability to integrate workflows with data management. The discovery environment supports movement of applications and input data sets to high-performance computing centers and manages the archiving of the results.